Welcome to Maths and Science by IITian. From this channel, now I will be taking up lecture number 5 in rotational motion. It will be useful for IIT JEE NEET Physics and also Physics Olympiad examinations. And in this lecture, I will be taking up certain important topics such as inertial frame, non-inertial frame, and what are their effects, and why inertial frame is to be defined in case of rotational motion, and why non-inertial frame to be defined, how they are defined, and what is the Coriolis effect. Coriolis effect. We will be discussing these things and deriving formulae for rigid body equations of motion. Ultimately, whether it is a linear motion, whether it is a rotational motion, we are required to find the equations of motion. In linear and in inertial frames, Newton's laws are there for us. For rotational motion and for non-inertial frames, how the equations of motion can be developed. That is one of the major topics to be covered in rigid body motion. And once you understand clearly the importance of the inertial frame, non-inertial frame and equations of motion, then you can understand the rotation motion very easily. Now, with this background, we will be proceeding further. In the diagram which on the left side I have shown you, this is the omega, angular speed, and this is the radial speed on the curve, and this is Coriolis effect, and we will discuss this. This is x-axis, this is y-axis. We will discuss this now. First point is inertial frame. What is an inertial frame? Because I told you from the beginning in the physics classes that there should be a reference frame. And in the last class also we have seen this reference frame. Let me draw it properly with z-axis also. This reference frame can be in the homogeneous space, isotropic space, and the shifting of the inertial frame can be like this also. This is O and this is O dash, this is X dash, this is Y dash, and this is Z dash. In a homogeneous space, when you shift the origin or axis from one place to another place in an inertial frame, the properties do not change for a particle. If a particle P is here and P dash is here, there won't be any change as long as OP and O dash P dash is same. And inertial frame, it will not have any acceleration. There will be no acceleration effect. Either inertial frame is at rest or moving with constant velocity. Constant velocity. But in case of non-inertial frame, this is homogeneous space, and there is another called isotropic space also, which I have explained in the previous classes. In case of non-inertial frame, frame is accelerating. Frame is accelerating. The acceleration can be, that means just see, this frame O to O dash, it is accelerating with some A. Either acceleration can be linear. Acceleration can be linear or rotational. That frame is accelerating. Frame is moving from one place to another place in an accelerated motion. Frame itself is moving. And another thing, you can think of this also. Please make these concepts very clear. Huh? This is Z. This is Y. This is X. And frame can be like this also. This is X dash, this is Y dash, and this is Z dash. And frame is rotating at an angle. It is moving, it is rotating with omega. A rotating frame will have an acceleration. A rotating frame will have an acceleration until and unless the acceleration does not have any effect on the property of the particle. Here also in homogeneous also same thing. If there is an effect on the property of the particle, definitely there is an acceleration. Translationally means that frame is non-inertial. And here also the frame is non-inertial. Either it is linearly here, moving at a constant acceleration, or rotationally here. In these two cases, inertial frame is not existing, it is a non-inertial frame. Now, the big question comes, Earth as we see, we feel it is constant. Earth, is it inertial frame? If we take Earth as the reference, is it inertial frame or non-inertial? Earth is non-inertial in literally sense because it is rotating. Because it is rotating, It's non-inertial, rotating in a curve. Hence, Earth is non-inertial. But as the force, centripetal force, is almost negligible because of the Earth's acceleration. It has got very less acceleration. Earth has got very less acceleration. As a homework, can you people find out acceleration value of Earth? Because it is rotating, a rotating particle or rotating object will have an acceleration. It cannot be without acceleration. Rotating means it involves acceleration. Then can you find? This is your homework. Do it. Feel the physics. Because this acceleration is very small, we do not feel it. Hence, we take all for practical purposes Earth as inertial. For all practical purposes, Earth is inertial. These things I have explained in the first class. Why I am repeating these? These are very, very, very important. Reference frame, inertial frame, non-inertial frame. These are the things very important in understanding the rotation motion. In linear motion, we are not much concerned, but as far as rotation motion, rigid body motion, we are required to know these things. And one problem we have solved either in the first lecture or a second lecture. That one, rigid body is rotating about an axis. Why it is rotating about an axis? Rigid body. It's having a linear motion, and at the same time the motion of the rigid body can be explained in the rotation also. It's not a particle. And the rotation of a rigid body, how it is happening? Here is the rigid body. I have drawn the diagram and I have solved the problem also. This is the axis through which body is rotating. About this axis, the body is rotating. And this axis is passing through certain point. That means your axis is fixed, or we have finalized an axis. About that axis, you have rotated the body, rigid body. This type of motion is called as rotating about an axis. When axis is defined, it is parallel to something and passing through some point. When axis is defined, about that axis, when the rigid body is rotated with some omega, then it is called as the rigid body rotation. And here the axis about the axis the rigid body is rotating. There is no translatory motion, there is a rotatory motion only. In that case, how you define that motion? For example, please try to understand this. I am writing on a big page. Please try to understand this. X and this is the axis through which rigid body is rotating. And while rotation, is the point P, let us say it is point P, are the coordinates of the point P are changing? No, they are not changing. The point is fixed. About the axis only there is a rotation. There is no translation moment of the particle P. Here, how do you define then the motion? Hence, to define this type of motion, we have to find the axis. Axis itself is the reference frame. That means, for understanding the rotation of a rigid body, equations of motion, we require a reference frame which is rotating about one of the axes. Reference frame is either it can be a axis or reference frame can be a rotating reference frame about one of the axes. Please try to understand. There is no translational motion here, but still it is subjected to acceleration. We have to define this acceleration. That is the crux of the rotation motion. We have to define this. To define this, we require a reference frame. That reference frame is the frame which will be rotating. That frame can be like this, or can be axis and this like this, or some frame like this. This frame will be rotating. This frame will be rotating about an axis. Here frame is not rotating, frame is stationary in the inertial frames. Here frame is rotating about one of the axes of the rigid body. And this rotation can be compared with a vector P. This rotation is compared with a vector P. Then the rate of change of vector. The rate of change of vector, please try to understand this. What is the rate of change of vector? dP by dt is equal to omega cross p. P is a vector, omega cross p. Because it is rotating about an axis, then this distance, if you call it as r, this vector as r bar, then dr by dt is equal to omega cross r. This is how, that means V is equal to omega cross r. This is how the velocity is linked to radius and angular velocity. Very important. Try to understand this. Very important concept. Once this is over, now what is the, as per Newton's law, what is the definition of the force? We will go into the linear motion. Force is defined as mass into acceleration. Let's say I have applied an external force, F is equal to ma. This is external force I have applied on the system. Applied on system. Then there will be some resistance offered by the rigid body for the motion, which you cannot neglect. Then the net force will be reduced, which is acting on the body. Net force is equal to m, let us say a net, acceleration net, that is the net force. Then this will be less than m a bar in the rotational motion. Then what are the factors which are reducing this rotation? In the rotating frame of reference, here frame of reference is rotating, it is non-inertial. Rotating means non-inertial. Frame of reference is equal to rotating frame of reference. Rotating frame of reference. Because of this rotation, mass you cannot reduce. Acceleration is divided into different parts. That directly I will give the equation. Please remember that ma net is equal to ma bar, this is external, minus 2m into omega cross v minus m omega cross omega r minus m into d omega by dt cross r. You please try to understand one by one. What are these? This is the external force. Because of the external force, this is Coriolis force. This is the centripetal force. and this force is due to change in omega with time. Now, let us discuss these one by one. This concept is very important. M A bar net is equal to M A bar minus 2M W omega cross B minus M omega cross omega cross R minus M into d omega by dt cross R. You only remember this equation, that is sufficient for you. It is not required to derive this equation. If derivation is required, then is wanted, then you please give a comment in the comment section. You please ask me, then I will provide at the end of completion of the syllabus. It is not required. Now, this will be 0 if omega is equal to constant. If the angular velocity remains constant in the rigid body motion, then this particular d omega by dt will become 0. Then the above equation is reduced to, for constant angular velocity, usually we will consider this only. Omega we will give some value 1.3 radians per second, 0.5 radians per second, like that, 3 radians per second. So that we will keep it constant. If for constant angular velocity, that means omega is equal to constant d omega by dt is equal to 0. Then MA net is equal to external force minus Coriolis effect minus centripetal force. Regarding the definitions of cross product, dot product, how the directions will be, I have given enough lectures in vectors, and I told many times that vectors is the backbone of the physics, and also for that matter mathematics. And another important thing to be noted, in a rigid body, I have already explained in the first lecture, the distance between the particles does not change until and unless the impact of the external force is very high. Under normal conditions, the distance between particles do not change. That means, and another thing we have found or we have learnt in rigid body motion is that the degree of freedom is equal to 6. To fix a rigid body, we require 3 points. To fix a rigid body, 3 points are required. This is the basis on which we will be moving ahead for studying the equations of motion for rigid body. And the most important equation is, now one by one we will write. The first is that the frame of reference to be rotating about an axis. That's what we have learnt for studying the equations of motion of rigid body rotation. And if there is a vector r, then dr by dt is equal to omega cross r. It is also very important derivation. Please don't change the order. And the net effect of equation of motion or net effect ultimately. What is equation of motion? I applied some force on the object and I want to see what's happening to it, how it is moving. Then equation of motion, which is very important, and we have just checked up. MA net is equal to MA external minus 2m omega cross r, sorry, it is V, not R, minus m omega cross r minus m d omega by dt into cross r. In this, if it is 0, then Coriolis effect, and then your centripetal force, this is external force, this is Coriolis effect, this is centripetal force, everything is force, Coriolis force, because if you check the dimensions, you will get the dimensions only. And this can be 0 if omega is equal to constant. With this equation of motion, sometimes in our questions, sometimes Coriolis effect is neglected. MA bar net is equal to, please, if Coriolis effect is neglected, MA bar minus m omega cross r. This is very important equation of motion. On the basis of this, almost all the questions in rigid body motion will come, and you should understand the each and every aspect of this particular equation. What is m, what is a, what is ma net, these things we have to provided. One is omega is taken as constant, and second, Coriolis effect is neglected. Then ultimately the simplified form of the equation of motion of a rigid body when Coriolis effect is neglected, and when omega is taken as a constant, it's not changing with time. MA net is equal to MA minus M omega cross R. This is centripetal force, which we will be discussing next. And this is external force. And this is the net force. Force always acts in the direction. Net force will always be in the direction of the motion of the body. Please remember that. That I will just explain to you for a minute. I will take a minute more. This is the simplified form. A body is there. This is applied with 20 newtons here, and it is applied in this direction with 5 newtons. Then the net force will be MA net is equal to 20 minus 5, 15 newtons. In which direction? In this direction. The direction also we have to give, it is a force. So net will be in this direction 15 newtons. This is FA net. FA net. MA net. It's not F. Force net. MA net. F net. So the body moves in which direction? The body moves in the direction of the net force. That's also very, very important. If you are given in the equation, I am writing repeatedly this equation, I want you people to remember it. MA external minus M omega cross R, and the centripetal force is lesser than the external force, then the body motion will be in the direction of the net. If the centripetal force is more, whether that happens or not, I will explain in the next classes. Homework: what happens when centripetal force, because these type of questions will come in your competitive examination, is greater than MA. Please let me know in the comments. It is external force, this is centripetal force. Is it possible to have that condition? Or if it is possible, what happens? If it is not possible, give me. It's not a possible solution. Best of luck to everybody. Thank you for listening to me. If any value addition took place because of my video, please subscribe to my channel, share and subscribe. Maths and Science by